Welcome to Griffonomics. Today we have just an absolutely massive stack of structural market data, federal executive orders, and private enterprise blueprints sitting in front of us.
Yeah, it's a lot to get through today.
It really is. And our mission for this deep dive is basically to build you a map. We are charting a highly specific 7-asset infrastructure play that's entirely designed to capture the whole Western nuclear life cycle.
Right, because the conventional wisdom around this whole sector is, well, it's deeply flawed.
Oh, completely. I mean, when people think about investing in the nuclear renaissance, they usually look for, the sexiest next generation reactor startup. They want a sleek blueprint.
Exactly. But that approach usually traps your capital in what the industry calls individual reactor design risk.
Right.
You end up betting massive amounts of money on these unproven pre-revenue startups. And they might have a brilliant idea on paper, sure.
But they could go entirely bankrupt from like a single nuclear regulatory commission licensing delay,
Yeah.
or even just a supply chain hiccup.
Exactly. It's a binary all-or-nothing bet. And our strategy today bypasses that startup trap entirely. Instead, we're looking at a framework that establishes an ironclad toll booth model.
Toll booth model? I love that term.
It is the absolute definition of a structural monopoly. And what is brilliant about the sources we are analyzing today is how they completely re-engineer the way capital interfaces with nuclear energy. Because by focusing on the toll booth, it mathematically does not matter which specific reactor design ultimately wins the commercial race.
Right, whether it's a water-cooled design or a molten salt reactor.
Or a high-temperature gas reactor.
Yeah.
Doesn't matter. Every single molecule of uranium utilized in Western commercial or defense applications, it must squeeze through the specific processing, engineering, and compliance bottlenecks controlled by this 7-stock portfolio.
I look at it like the ultimate pick and shovel play during a gold rush, We all know the old adage, don't buy the gold miners, buy the people selling the shovels. But this portfolio introduces a massive twist to that old metaphor. In this particular gold rush, the government legally mandates that the miners buy your specific shovels.
Yeah.
And the technological physics literally dictate that no other shovels will actually work.
That is the perfect way to frame it. I mean, to understand how tightly constrained this ecosystem is, we really have to trace the exact life cycle of the fuel, step by step.
Okay, let's do it.
We are going to track this from raw dirt sitting in a secure vault, through the chemical transformation, into the heavy foundries, out to the civil construction sites.
And finally, into the highly automated compliance networks that actually keep the reactors legally integrated into the commercial grid. Because you physically cannot power a reactor without the raw material, so we have to begin at the absolute front of the value chain.
Right, what the industry calls the fuel engines.
Exactly. So let's look at the entry hurdles here. The very first stage, what we'll call stage 0, starts with an asset that doesn't actually produce anything at all. No factory, no CEO trying to maximize quarter-over-quarter widget sales, no operating margins. It is the Sprott Physical Uranium Trust, trading under the ticker SRUUF.
Right, and SRUUF is incredibly unique in the global energy ecosystem because it is a passive, closed-end physical trust. Its entire scale and value are measured by its total net asset value, or NAV. And right now, that NAV sits at a staggering $7.11 billion.
$7.11 billion. And that's backing roughly 81.4 million pounds of physical yellow cake uranium, which is chemically known as U3O8.
Correct.
Now, the immediate question I think any logical investor would ask you is, why is a passive holding trust sitting at the head of an infrastructure portfolio? Like, why would we just go upstream and buy stock in a massive uranium mining conglomerate that pulls the stuff out of the ground?
Because of the execution risk inherent in heavy extraction.
Yeah, intact that.
Well, by holding physical vaulted metal in secure Western facilities, SRUF provides pure macro pricing power while completely eliminating the operational nightmares of mining.
Right.
I mean, consider the physical reality of uranium extraction. You are dealing with highly complex geology. You can spend $1 billion sinking a shaft only to hit a catastrophic water ingress that floods the entire operation.
Which is something we've seen historically at major Canadian sites, right?
Exactly. You have extreme capital cost overruns, just trying to get heavy machinery operational in remote locations.
Yeah.
You have the constant threat of organized labor disputes shutting down production for months.
And that's just the physical engineering side. You also have severe geopolitical instability if the ore body is located in a volatile jurisdiction.
Oh, absolutely.
You could spend, what, 10 years exploring, permitting, and building a mine in a developing nation, and the moment it actually becomes profitable, the local government decides to nationalize the asset.
Or they levy an aggressive windfall tax.
Right. And suddenly, your investment thesis isn't about the global price of uranium anymore. It's basically devolved into a gamble on local municipal politics and labor relations.
Exactly. When you buy a miner, you are taking on idiosyncratic corporate risk. SRUUF strips all of that away. It acts as a pure play on the structural global supply deficit.
So you're just betting on the raw supply and demand.
Yes, you are getting undilutable exposure to the simple mathematical reality that the world's nuclear fleet currently consumes significantly more uranium that is being pulled out of the ground globally.
And crucially, looking at our sources, they note a really unique financial mechanic here. Because of market inefficiencies, this asset is frequently acquired at a structural discount to its actual net asset value.
Which is huge. You are essentially buying a dollar's worth of physical, audited, vaulted uranium for less than $1.
Without ever having to worry if a dump truck breaks down at the mine site.
Or so.
Okay, so we have the raw material safely locked in a vault, entirely insulated from mining failures. But yellowcake is just a dense, heavy powder. You can't just shovel U3O8 powder into a modern nuclear reactor and expect it to generate heat.
No, you definitely cannot.
It has to be completely transformed at a molecular level. And that brings us to the first active bottleneck in the portfolio, Stage 1 Solstice Advanced Materials, ticker SOLS.
Right, Solstice.
I was looking at their footprint, and they have a trailing 12-month revenue base of $3.84 billion. But here's the interesting wrinkle. They are not a pure-play nuclear company.
No, they are not, and that is a critical distinction to make. Their nuclear exposure is only about 10% of that $3.84 billion revenue base.
Okay, so what's the other 90%?
The vast majority of their business is heavily anchored in advanced materials, specifically AI data center liquid cooling infrastructure.
Which is a fascinating high-growth secondary tailwind entirely on its own.
Right.
Because if you are building high-density AI clusters, air cooling no longer works. You need advanced chemical liquid cooling, which SOLS provides.
Exactly.
But let's set the AI data centers aside for a second and look under the hood of that 10% nuclear slice, because this is where the physical bottleneck gets incredibly tight.
It's the chemical conversion bottleneck. Like you mentioned, raw yellowcake is a solid powder. And in order to enrich uranium so it can sustain a nuclear chain reaction, you have to separate the fissile isotopes from the non-fissile ones.
Right.
And that separation happens in high-speed centrifuges. But centrifuges rely on microscopic differences in mass, and you physically cannot spin a solid powder to separate isotopes.
It just wouldn't work.
It wouldn't work. The uranium has to be chemically converted into a fluid, specifically a highly volatile gas called uranium hexafluoride, or UF6.
And SOLS controls this chemical tollbooth. They operate the Converden facility, which is essentially the absolute gatekeeper for American nuclear fuel processing.
Yes.
I really want to emphasize this for you listening. Uranium legally and physically cannot move downstream to the enrichment phase without first undergoing this highly toxic, complex hydrofluorination process to become UF6 gas.
Mandatory step.
And SOLS operates the only facility in the United States capable of doing this at scale.
The barrier to entry here is nearly insurmountable. You cannot simply stand up a competitor to convert in tomorrow.
Right, the red tip alone.
The environmental permitting, the handling of hydrofluoric acid, the sheer scale of the chemical engineering required to safely manage radioactive gas, it takes decades to permit and build.
Wow.
And SOLS is currently aggressively expanding this capability. The sources highlight that they are targeting a massive 10-kiloton production threshold to directly address the Western supply deficits.
Because the utilities are scrambling, right?
Exactly. They are capitalizing on the fact that global utilities are terrified of relying on Russian or Chinese conversion facilities and are desperately trying to secure domestic chemical capabilities.
Okay, so let me make sure I've got this right. If SRUF is the highly secure underground vault holding the crude oil, SOLS is basically the only permitted refinery in the hemisphere allowed to crack it into usable gasoline.
That analogy holds up perfectly. And just like crude oil becoming gasoline, once you have that UF6 gas, it still isn't ready for the engine. It needs to be refined and concentrated to make it combustible, or in this case, fissile, which takes us from the chemical layer into the physics layer. Stage 2, centrus energy, ticker LEU.
Centrus energy. Okay, now we're looking at a $452.3 million trailing revenue footprint. And unlike Solstice, LEU is a 100% pure-play nuclear asset.
Right, completely focused.
They do not have data center cooling divisions. Their entire existence is dedicated to the nuclear fuel cycle.
Their specific role is uranium enrichment. They take that volatile UF6 gas produced by SOLS and they introduce it into cascades of high-speed centrifuges.
Okay.
To visualize this, imagine thousands of towering cylindrical machines networked together, spinning rotors inside a vacuum at supersonic speeds.
We are talking about tens of thousands of revolutions per minute, correct?
Often much faster. The sheer centrifugal force pushes the heavier uranium-238 isotopes toward the outer wall of the cylinder,
Okay.
while the slightly lighter fissile uranium-235 isotopes gather near the center where they are actually extracted.
That is wild.
It is, but it is a process of diminishing returns. It requires the gas to pass through thousands of these centrifuges to slowly concentrate the U-235 to a usable level.
And this is where the geopolitics of the toll booth really snap into focus. Centrus, they produce standard low-enriched uranium, which sits at about 3 to 5% concentration and powers the massive legacy commercial reactors operating today.
Right.
But standard enrichment isn't their true moat. Their geopolitical superweapon is their domestic monopoly on HALEU.
High-assay low-enriched uranium.
Yes.
This is the linchpin for the entire future of the industry.
Mm-hmm.
HALEU is a specialized fuel enriched to between 5 and 20%. And the reason LEU is an irreplaceable geopolitical asset is that HALEU is strictly required to power next-generation small modular reactors, or SMRs.
Let's drill into that for a second. Why do SMRs absolutely require HALEU? Why can't they just use the legacy 5% fuel that the big legacy plants use?
It comes down to power density and reactor geometry. The entire value proposition of a small modular reactor is that it is, by definition, small. It has a much more compact core. To achieve a sustained nuclear chain reaction in a smaller physical footprint over a longer period of time without constantly refueling, you need a much higher density of fissile material.
Oh, wow.
Standard fuel simply doesn't have the neutron economy to sustain the reaction in a microcore.
So if a tech giant or, say, an industrial manufacturer wants to deploy a futuristic, highly efficient SMR to power their remote data center or factory, that reactor physically cannot turn on without HALEU.
It cannot.
It's not a suggestion. It's a thermodynamic requirement. And
Yeah.
Centrus is the only domestic facility licensed and capable of producing it.
Precisely. They are the high beta technology engine of this fuel cycle. By capturing stages 0, 1, and 2 Sprott, Solstice, and Centrus, this portfolio strategy completely locks down the chemical and physical inputs of the nuclear renaissance.
You own the raw dirt, the chemical gas conversion, and the supersonic enrichment.
Exactly.
But a reactor isn't just a cloud of radioactive gas and some advanced physics equations on a chalkboard. It is massive, unimaginably heavy physical infrastructure.
Oh, absolutely.
The enriched gas has to be hardened, housed, and forged into something a utility can actually build a facility around. So we are leaving the high-velocity fuel layer and entering the deep-value structural anchors of the portfolio. Let's look at the heavy foundries and the civil construction layers.
This transition leads us to stage 3 with BWXT Technologies, ticker BWXT. This is the heavy foundry.
Okay.
They operate with a $3.38 billion trailing revenue profile. And what makes them incredibly defensive is that approximately 95% of their business is completely housed within nuclear defense and commercial systems.
When we talk about a heavy nuclear foundry, what is actually happening on the factory floor? Because this is a very different type of manufacturing than stamping out car parts or assembling iPhones.
That's totally different. They absorb that enriched material from the upstream fuel cycle and manufacture it into active hardened components.
Like what specifically?
We are talking about precision forging. The heavy nuclear reactor cores, the massive multi-ton containment vessels, and the hyper-complex internal structural components that must withstand extreme radiation and thermal stress for decades without degrading.
Wow.
And perhaps most importantly for the commercial future, they fabricate advanced TRISO fuel.
TRISO fuel is fascinating. The sources describe these as meltdown-proof fuel pebbles. And I know meltdown-proof sounds like marketing hyperbole or like science fiction.
Right.
But it is a literal engineering reality based on material science. How does a TRISO pebble actually prevent a meltdown?
TRISO stands for tristructural isotropic. Instead of putting uranium into long metal rods, which can melt if the cooling system fails, BWXT manufactures the uranium into microscopic kernels.
Okay.
Each individual kernel is then coated in 3 distinct layers: a layer of porous carbon, a layer of dense pyrolytic carbon, and a layer of silicon carbide.
So each tiny piece of fuel has its own microscopic containment vessel built around it.
Exactly. And the melting point of that silicon carbide shell is physically higher than the maximum temperature the nuclear reactor can ever theoretically reach, even if all cooling systems completely fail.
That is incredible.
The physics of the reactor core shut down the reaction before the heat can breach the silicon carbide. It is a passive structural impossibility for the fuel to melt.
That fundamentally changes the safety profile and, frankly, the insurance economics of building a new reactor. But as incredible as the commercial applications for TRISO are, the most staggering part of the BWXT thesis isn't their commercial pipeline, it's their national security moat.
It is arguably an unbreakable federal mandate. BWXT supplies 100% of the nuclear reactor cores and propulsion systems for the United States Navy's submarine and aircraft carrier fleets.
I really want to pause on that for a second. Not a majority share, not a dominant market position, 100%.
Every single one.
Every single nuclear-powered vessel in the United States military relies on a reactor core forged by BWXT.
The barrier to entry to become a certified prime contractor for naval reactors is effectively infinite. The security clearances, the specialized metallurgical expertise, the decades of pristine safety records, you simply cannot replicate it.
No.
This provides BWXT with a deeply stable, government-funded bedrock of revenue. The U.S. Navy is not going to stop building submarines.
Right.
And what this investment strategy does is leverage that defense monopoly. BWXT uses that incredibly stable, recession-proof cash flow from the Pentagon to capitalize their commercial expansion.
That is the genius of the toll booth right there. They take their unrivaled expertise in building highly specialized, compact military reactors for submarines, and they just pivot that exact same production line toward mass-producing assembly line, small modular reactor containment units for the commercial grid.
Exactly.
They already have the foundries, the N-stamp welding certifications, the nuclear-grade metallurgists. They don't have to build a factory from scratch like a startup does. They just allocate factory floor space.
But even with a perfectly forged containment vessel and a batch of TRISO fuel pebbles, you still just have massive pieces of high-tech metal sitting in a factory in Virginia.
Yeah.
It needs a home. It has to be transported, integrated into a physical site, wired to a turbine, and connected to the electrical grid.
And that brings us to the muscle of the operation. Stage 4 Amentum Holdings, ticker AMTM. This is the civil anchor.
Oh.
I was looking at the financials here, and the numbers are just mind-boggling.
They really are.
They have a $14.28 billion trailing revenue powerhouse, and their corporate backlog stands at a staggering $47.8 billion.
That $47.8 billion backlog is the key to understanding Amentum's indispensable place in this portfolio. Amentum is a mega-scale government services and heavy engineering contractor. And within their massive global footprint, roughly 15 to 20% of their revenue is derived from highly specialized nuclear, environmental, and engineering solutions.
So if BWXT is doing the highly technical, microscopic forging of the reactor core in a call room, what exactly is Amentum doing out in the mud?
Amentum is the blue-collar, heavy engineering footprint. Once a utility company or a tech hyperscaler selects a reactor design and finally clears the brutal pipeline of the Nuclear Regulatory Commission, Amentum provides the essential EPC engineering, procurement, and site construction.
Okay.
They are the logistics masters. They clear the physical site. They are pouring the millions of tons of nuclear-grade concrete.
And pouring nuclear concrete is not like pouring a sidewalk or the foundation for an office building. We are talking about continuous, massive pours of heavily reinforced concrete that must cure perfectly to avoid microfractures, right?
Yes, absolutely.
Because it acts as the ultimate radiation shield and structural support for the containment dome.
The quality assurance documentation required just for the rebar and the concrete mix is thousands of pages long. Amentum executes that flawless civil construction. They also handle complex environmental remediation and manage the federal facility infrastructure.
They have the workforce for it.
Exactly. They possess the massive, skilled, unionized labor force, the specialized pipe fitters, the certified welders, the heavy crane operators required to physically assemble the plant.
You know, it's funny. You can have the most brilliant quantum physicists design the perfect reactor blueprint in a simulator. But if you don't have a workforce capable of laying a physical foundation that meets strict NRC Part 52 regulatory standards, that pristine blueprint will never generate a single watt of power.
That is exactly right. Amentum turns the paper blueprint into a physical, breathing power plant. But once that plant is built, the concrete is cured, the vessel is installed, and the nuclear core goes critical, a massive new problem arises.
The radiation.
Yes.
Once the core goes critical, human beings physically cannot touch the hardware anymore. If a fuel rod needs to be repositioned or spent waste needs to be packaged for storage, a technician cannot just walk into the containment zone with a pair of thick gloves and a wrench.
No, the biological exposure limits make manual intervention completely illegal and fatal.
Which forces the entire facility to rely on a highly specialized secondary layer of infrastructure. And this leads us directly into a strict audit of Stage 5 operations, the automated machinery and software that keep these plants legally running day to day. We call this the safety and compliance layer.
This is where we separate the hardware from the software. Let's look at the Stage 5 hardware first. Cadre Holdings, ticker CDRE.
Okay.
They operate a $635.6 million revenue footprint. And our sources note that about 20 to 25% of that revenue is anchored by their alpha safety divisions.
I looked into alpha safety, and it's fascinating because it's entirely built around extreme environmental isolation. What exactly are they manufacturing for these plants?
They manufacture the automated remote handling robotics. If you have ever seen footage of a nuclear facility, you see these heavily shielded containment enclosures called hot cells, featuring windows made of thick leaded glass.
Yeah, you see them in the documentaries.
Right. Inside those cells, you have master-slave telemanipulators. These are complex robotic arms that mimic the exact hand movement of a human operator sitting safely outside the shielded wall.
So the operator moves their hand up and closes their fingers, and the robotic claw inside the radioactive zone moves up and grips the fuel rod, providing haptic feedback so the operator can actually feel the resistance of the object they are holding.
Precisely. Because human operators cannot safely interact with spent fuel assemblies, contaminated cooling hardware, or medical isotopes, these facilities require this hyper-specialized automation just to perform routine maintenance.
And I want to clarify something here for you listening. Upgrading to this robotics package isn't like a factory deciding to buy a new circ lift to improve efficiency. This isn't a nice-to-have optional upgrade.
Absolutely not. This is high-margin, legally mandated machinery. Facilities are contractually and legally bound by regulatory agencies to purchase these exact remote handling systems to manipulate fuel rods and manage waste without exposing humans to radiation.
So they have no choice.
None. If a master-slave manipulator breaks, the plant cannot legally operate that hot cell. They must buy replacement parts, specialized joints, and maintenance services from Cadre. It creates a deeply captive, recurring revenue stream.
So Cadre provides the mechanical hands of the power plant. But a plant also needs eyes and ears. It needs a sensory nervous system to detect what the human operators cannot see, smell, or feel.
Right.
That brings us to Stage 5 software Mirion Technologies, ticker MIR.
Mirion integrates directly alongside Cadre's hardware layer. They have a $981.0 million revenue baseline, with about 40 to 45% of that completely housed within their industrial and nuclear monitoring segment.
When we talk about the sensory nervous system of the grid, what does that actually look like day to day for a nuclear worker? How does Mirion interface with the facility?
It covers the entire spectrum of ionizing radiation detection and tracking. On an individual micro level, it's the wearable worker dosimetry badges, the TLDs or OSLDs, that track personal radiation exposure minute by minute. On a macro facility level, it's the continuous localized environmental sensors stationed around the perimeter, the stack monitors checking for gas emissions, and the massive data analytics enterprise software networks that aggregate all this data to monitor the health of the entire plant.
And their economic moat is staggering. The sources explicitly note that Mirion's hardware and software are installed in over 90% of operating nuclear facilities globally.
Yeah, massive.
Over 90% market share. In enterprise software, anything over 30% is considered dominant. 90% is effectively an industry standard.
And this creates an incredibly powerful dynamic for an investor, highly predictable recurring revenue. The Nuclear Regulatory Commission and equivalent bodies globally strictly mandate continuous, highly accurate radiation tracking to prevent immediate plant closure.
So the plants are locked in.
Completely.
Yeah.
Utilities are essentially forced into continuous software licensing agreements, constant hardware calibration cycles, and mandatory equipment upgrades with Mirion. You cannot switch vendors easily because the historical dosimetry data of your workforce and the plant's baseline environmental data are all siloed within Mirion's proprietary systems.
Okay, let me push back on this thesis for a second. Everything you just said makes Mirion sound like a phenomenal subscription service that utilities can literally never cancel. It's an incredible cash cow.
Right.
But is this growth actually resilient moving forward, or are we just looking at a static, flat baseline of legacy plants that were built in the 1970s and 80s, slowly aging out of the system? If no new plants are built, Mirion's growth just plateaus and eventually declines.
That is exactly the vulnerability you would face in a stagnant market. If the nuclear industry were just managing a slow decline, Mirion would be a high-yield value trap, not a growth engine. But this raises the most important question of our entire analysis. What happens when the entire regulatory and geopolitical landscape fundamentally shifts to force the rapid construction of new plants and the restart of dead ones?
And that brings us to the massive catalyst driving this entire thesis, the sovereign tailwinds. Having mapped out this 7-stock toll booth portfolio, we have to look at the structural forces unleashed by the White House that are primed to cause an explosion in demand. We are dealing with raw federal mandates here.
We have to impartially examine Executive Order 14302, titled Reinvigorating the Nuclear Industrial Base. Treating this purely as factual structural market data, this executive mandate establishes an aggressive, time-bound framework to force the jumpstart of domestic nuclear capacity.
Reading through the mandate, the administration essentially diagnosed the multi-decade stagnation of American nuclear infrastructure as a critical vulnerability to national security and global technological supremacy.
Yes.
They aren't just suggesting growth, they are issuing mandates with hard numbers. They are directing the Department of Energy to facilitate 5 gigawatts of power uprates to existing operational commercial reactors by 2030.
But the more staggering target within that executive action is the mandate to ensure that 10 new large commercial reactors with complete designs are actively under construction by 2030.
10 new reactors, that's huge.
Right. And to support this massive industrial pivot, the Department of Energy's Loan Programs Office is prioritizing activities backed by a $17.5 billion loan program.
Okay, I have to challenge this again. $17.5 billion in federal financing sounds incredible. It is meant to fast-track these large reactors, restart closed plants, and improve the supply chain.
Right.
But an executive order is just a piece of paper, and a loan program isn't a magic wand. We have seen massive government-backed clean energy initiatives become horrific boondoggles in the past. Billions of dollars wasted on companies that go bankrupt because the market execution fails. What actually makes this intervention different? How are they forcing the private market to actually move and deploy capital?
They are doing it by weaponizing the Defense Production Act of 1950. Specifically, the administration invoked Title VII of the DPA to allow the creation of voluntary agreements, effectively forming industry consortia.
Stop right there. The Defense Production Act is usually reserved for wartime mobilization. How does invoking Title VII fundamentally change the economics for our 7 stocks?
It changes the economics by granting antitrust-exempt status to domestic nuclear fuel processing companies.
Oh, wow.
Yeah, it allows companies that would normally be fierce competitors to legally collude and coordinate capacity expansion across milling, conversion, and enrichment without any regulatory friction from the Department of Justice.
That's unprecedented in peacetime.
It is. But crucially, to solve the execution risk you brought up, to de-risk the massive private capital expenditure required to actually build these facilities, the government is stepping in with its own sovereign wallet.
Right. The sources explicitly detail the deployment of sovereign offtake guarantees. The Secretary of Energy is now authorized to provide procurement support, massive forward contracts, and explicit purchase guarantees to these newly established domestic fuel lines.
Think about the mechanics of what this means for a company like Centrus LEU or Solstice SOLS. Building a new chemical conversion facility or a massive centrifuge cascade costs billions of dollars up front.
And years of time.
Exactly. Historically, a private company's board of directors would hesitate to approve the capex, fearing that by the time the factory is built 5 years later, market demand might have dried up, leaving them bankrupt.
Right.
But with sovereign purchase guarantees, the federal government is essentially saying, if you front the capital to build a facility, we legally guarantee we will buy the end product at a fixed, profitable price for the next decade.
That is massive. It creates a state-backed revenue floor that heavily de-risks their corporate expansion.
Exactly.
That is a phenomenal backstop for the fuel layer. But there is another massive regulatory pivot buried in this executive order, and it has to do with the back end of the life cycle, the waste.
Yes, the spent fuel recycling pivot. Historically, United States policy treated used nuclear fuel purely as a long-term storage liability. You take it out of the reactor, put it in a dry cask, bury it, and forget it.
Out of sight, out of mind.
Right. But this executive order initiates a historic national regulatory pivot towards spent nuclear fuel, recycling, reprocessing, and high-value isotope extraction.
The sources mentioned they are also halting legacy surplus plutonium dilution programs, basically preserving that fissile material to fabricate new fuel for advanced nuclear technologies.
They are.
But connect the dots for the listener. How does reprocessing spent fuel actually drive revenue for our specific portfolio?
It dramatically expands the long-term addressable pipeline for our automated waste and safety layers. The chemical physics of reprocessing spent fuel, such as the PRX process where you dissolve irradiated fuel in nitric acid to separate the uranium and plutonium. It creates a highly radioactive, complex chemical environment.
Right, you can't have humans anywhere near that.
Exactly. If you're no longer just burying spent fuel in a concrete cask, but instead transferring it to government-owned, privately operated reprocessing facilities to harvest high-value isotopes, you introduced massive new handling requirements.
Oh, I see the connection now. To harvest and process recycled nuclear fuel safely, these new recycling facilities will be legally required to purchase fleets of the hyper-specialized remote handling robotics and hot cells from Cadre.
Yes.
And they must deploy entirely new, continuous, highly sensitive radiation monitoring software networks from Miriam.
Exactly. A sovereign regulatory shift in how a nation handles waste management triggers a massive legally mandated procurement cycle for CDRE and ERR.
So we have federal mandates pushing the supply side, backing loans, and rewriting waste policy. But government policy alone doesn't guarantee a vibrant, sustainable commercial market.
No, it doesn't.
That requires actual aggressive enterprise demand. Which brings us to the final major catalyst, the commercial PPA squeeze.
And this is where the dynamic shifts away from government action and entirely into the realm of private sector capitalism. We are witnessing the rapid emergence of a bespoke, bilateral corporate power market that is operating entirely outside the traditional utility models.
Enterprise giants, the biggest companies on Earth, are looking at the public grid and realizing it physically cannot support their future energy needs.
Right.
The grid interconnection queues take years, the transmission lines are congested, and the baseload reliability is faltering. So they are using their fortress balance sheets to bypass traditional public grids entirely. They are locking down continuous, clean baseload capacity directly from the source.
Let's look at the retail blueprint first, because this isn't just a Silicon Valley AI phenomenon. We have to examine Walmart's historic 15-year power purchase agreement, or PPA, with Constellation Energy.
The mechanics of this deal are fascinating. Walmart secured 176 megawatts from the Dresden Clean Energy Center in Illinois, but they didn't just sign a contract to buy existing electricity off the local grid.
No, they didn't.
The actual mechanics involve Walmart using their private corporate capital to fund active reactor efficiency upgrades.
Right. They're paying for thermodynamic efficiency and capacity upgrades within the existing operational Dresden reactor. Perhaps that means upgrading the steam turbines or optimizing the thermal transfer systems.
Wow.
This private capital injection actively adds 30 megawatts of newly generated unexpanded capacity to the grid that literally did not exist before Walmart paid for it.
And the logic behind why Walmart is doing this is crucial.
Yeah.
They are building a massive, high-tech, perishable distribution center in Belvidere, Illinois.
Yeah.
They need absolute, uninterruptible cold chain logistics reliability. They cannot afford grid pricing spikes, and they certainly cannot afford rolling capacity blackouts when they are managing tens of millions of dollars of frozen inventory. Nuclear power guarantees their cold chain never breaks.
So that's the retail efficiency uprate model. Now contrast that with big tech's aggressive infrastructure restarts, the AI squeeze. The power demands for training artificial intelligence are so vast that uprating a few megawatts isn't enough. They need entire power plants.
This is where the numbers get astronomical. Let's talk about Google's deal with NextEra Energy.
Google signed a massive 25-year PPA to completely finance NextEra Energy's recommissioning and restart of the 615-megawatt Blaine Arnold nuclear plant in Iowa. Now, it is crucial to understand that Duane Arnold was completely shut down and formally entered decommissioning status back in 2020.
It was a dead plant. The core was cold.
Exactly. Unlike the Walmart uprate, which improves a running engine, this requires a massive multi-billion-dollar capital expenditure to rebuild and restart offline degraded hardware.
I can't even imagine the logistics.
Every inch of pipe has to be inspected, analog systems replaced with digital, and the NRC has to relicense the facility. Google's 25-year financial commitment provides the exact economic certainty and cash flow. Next year, I needed to justify bringing that plant back from the dead by 2029 solely to power Google's AI data centers.
And Google isn't operating in a vacuum. We have parallel market-clearing precedents happening simultaneously across the tech sector. Microsoft signed a 20-year PPA for 835 megawatts to completely resurrect 3 Mile Island Unit 1, which they are now calling the Crane Clean Energy Center.
Right. And we also have Meta executing a massive 2.6 gigawatt multi-facility procurement deal with Vistra to backstop their global digital operations.
And then there's Amazon Web Services. AWS took perhaps the most aggressive route by completely bypassing public transmission lines. They acquired a 960-megawatt data center campus positioned directly behind the meter at Talon Energy's Susquehanna plant in Pennsylvania.
Just incredible.
They are literally building their servers next to the cooling towers and drawing power straight from the nuclear reactor's switchyard, meaning they lose zero power to transmission line degradation and pay zero grid transmission fees.
If we connect all these individual corporate actions to the bigger picture of our portfolio, you have to look at the extreme pressure this puts on the utility supply chain.
Right. If big tech uses their infinite cash reserves to lock up the end product, the electricity utilities are forced to run these reactors at 100% capacity forever just to meet these corporate contracts.
Yeah.
They cannot idle the plant during periods of low residential demand because Amazon servers never sleep.
And running at maximum capacity 247 creates a permanent, unyielding structural demand floor for the fuel. This completely squeezes the fuel buyers upstream.
It effectively guarantees the revenue loops for our entire 7-stock toll booth.
Well,
Because to keep that Susquehanna reactor running at 100% for Amazon, the utility needs constant raw uranium from the Sprott Trust, constant chemical conversion from Solstice, continuous supersonic enrichment from Centrus,
heavy maintenance hardware and Triso from BWXT.
site engineering from Momentum, and 247 compliance tracking from Cadre and Mirion. The tech giants are effectively paying for the entire life cycle without taking ownership of the underlying reactor design risk.
Which brings us to the final synthesis. We must distill this entire 7-stock investment case into a definitive summary of the portfolio architecture for the listener. How does an investor structurally manage this?
The sources outline a structural defense mechanism that they call duration rebalancing symmetry, often referred to as the S-curve.
The beauty of this portfolio is that it is elegantly balanced between two distinct economic timelines. On one side, you have the high-velocity, macro-sensitive, short-duration fuel layer, SRUUF, SOS, and LEU.
Right.
These companies capture immediate macro demand shifts quickly. When utilities scramble for fuel or uranium spot prices spike, their top-line numbers move rapidly.
But because they are tied to commodity prices and require massive capital expenditures to scale up centrifuges and chemical lines, they are highly volatile. They are high beta assets that can experience sharp cyclical pullbacks during broader market downturns.
Which is exactly why they must be perfectly counterbalanced by the deep value, cash-flowing structural anchors, AMTM, BWXT, and MIR.
Momentum and BWXT are sitting on multi-billion-dollar, multi-year backlogs backed by sovereign state and military contracts. Mirion is collecting sticky, subscription-style regulatory safety revenue.
Right.
These companies do not recognize their massive revenues overnight. They burn through their backlogs predictably over a period of years, providing a deeply defensive floor that is completely insulated from daily spot price volatility.
So the execution mechanism for the investor is quite brilliant. Housed within a tax-sheltered account, an investor can harvest the predictable cash flows and dividends generated by the structural anchors like Momentum and Mirion to systematically accumulate the cyclical dips in the high-beta fuel layer like Centrus and Solstice over time.
You are essentially using the steady, predictable muscle of the portfolio to buy the volatile, high-growth engines when they are on sale.
It's an ironclad ecosystem that feeds itself.
Okay, we have covered a massive amount of ground today, tracking the physics and economics of uranium from a dark underground vault all the way to a server farm rendering artificial intelligence. But before we wrap up this deep dive, I want to leave you, the listener, with a final, somewhat provocative thought to mull over.
I'm intrigued. What's the final takeaway?
We've talked extensively about how enterprise entities like Amazon, Google, and Meta are using billions of dollars to bypass public grids, securing their own behind-the-meter nuclear reactors to power autonomous AI.
Yeah.
If this trend continues and these tech giants secure absolute, uninterrupted baseload power independence, are we watching the birth of corporate sovereign states?
That is a profound question. I mean, energy independence is traditionally the defining characteristic of a nation-state. When a single technology company controls its own uninterrupted nuclear baseload power, completely independent of the national grid, and uses that power to drive artificial superintelligence, it fundamentally rewrites the rules of global energy diplomacy and corporate power. They are no longer just software companies selling ads or cloud storage. They are sovereign energy entities.
It really puts a new spin on that old gold rush metaphor, doesn't it?
Right.
We aren't just selling picks and shovels to miners panning for gold in a muddy stream. We are selling the mandatory toll booths to the corporate empires, building the digital future. And as long as they need power, they have to pay the toll.